quadratic formula came out to be either integers or cute little fractions? Okay, so today we're going to have answers that are irrational. So we're going to have radicals in our answers. And we're going to focus on how to do that. The good news is the beginning is exactly the same. Okay, and then we'll just have a little bit of different simplifying steps at the end. Okay, so just to remind ourselves why we use the quadratic formula, because sometimes factoring doesn't work. If we try to find magic numbers for this to see if we can factor it into binomials, and we slide that 3, we get negative 15, right? Are there factors of negative 15 that sum to negative 1? So like 1 and 5, 1 and 15, 3 and 5. Oh my gosh, it's really going to bother me, that 3. Is there a combination that will get us what we want? So this one has no magic numbers, so we can't solve it by factoring. Well, what about completing the square? Is our A value 1 with an even B? No, our A is 3 and our B is way odd. So this one's a no also. Before we go and say something rash, like there's no solution, we should probably check on the calculator to make sure whether we have solutions or not. So go ahead and make your 0 a y and put this in the calculator and see if it crosses the x-axis at all. It never fails that on this test, I will have a kid or two that on like 3 or 4 problems, because they don't get an answer path right away, they'll just start writing no solution. You know what happens to that kid? Every time, no, they don't die. Every time they write no solution, I'm like minus all the points, because they've got no work. There's nothing to show me that they understand anything that we did in this unit. Okay, so before you write no solution, you better put it in the calculator and make sure as beep that there isn't one. You know what I mean?
Yeah.
Okay, so you should get something that looks kind of like this. It's kind of crooked though. What does it look like? Okay, it looks like that. It's kind of like lopsided a little bit. Okay, so we definitely have 2 real solutions. What works on everything?
The last thing that we learned about.
Yeah, the quadratic formula.
Yep, that sounds right.
Okay, so let's try some examples, and we'll write down the steps too. Okay, step 1. We need standard form set equal to 0. So we need ax squared plus bx plus c set equal to 0. If we don't have that, how are we going to know what our a, b, and c are?
You won't.
Thank you. Okay, do we have that here? Yes. Okay, step 2. We are going to divide out a GCF if possible. Remember that we are allowed to divide both sides by the same number. So if we can do that before using our quadratic formula, then we will have smaller numbers and less reducing at the end. What happens if you have 2 big numbers, you multiply them together, and you're also multiplying by 4? Monster giant number. Okay, monster giant numbers have lots more factors to check, right? And we're going to be simplifying and doing all kinds of stuff. Don't make more work for yourself. Just divide out the GCF, because you have to divide it out for factoring and for completing the square anyway. Just make that what you do no matter what. Less to remember. Okay, do we have a GCF to divide out?
No, we do not.
Thank you. So the next thing we're going to do is find the A, B, and C and plug them in. Okay, so the formula goes, let's do the A, B, and C first before I get ahead of myself. The A is 3. The B is,
1.
what kind of 1? -1. Good recovery. What about the C? -5. Okay, X equals the opposite of our B. If our B is already negative, it'll be positive. Plus minus, big square root. Okay, when you square your B, remember to put it in parentheses. If you try to square a -1 without parentheses, your sign will be wrong and it will mess up your whole problem. Okay, -4 times our A of 3 times our C of -5. The whole thing divided by 2 times the A. Okay, it's time for me to talk to you about a health crisis that is attacking Algebra 1 students across the nation. Many Algebra 1 students are suffering from a chronic debilitating illness called receding fraction bar syndrome.
Uh-oh.
So what happens is the first time they write it, the fraction bar, they make it long and strong across the whole thing, and then gradually it starts to shrink. And then they forget that the whole thing has to be divided by the denominator. Okay? Don't let this happen to you. Make sure that you keep your fraction bar across the whole side. Got it?
Yes, got it.
Okay. And if it's happening to someone you love, make sure you get them the care that they need. All right, this part under the radical can be put in the calculator. Okay, so you're going to simplify what's under the radical. What did you guys get? I got 61 too. So you should get x equals 1 plus or minus the square root of 61, the whole thing over 6. Okay, now the last step is going to be to simplify further if you can. Simplify more if possible. Okay, what do I mean by that? Is 1 or the 1 in front of the root 61 divisible by 6? No. Okay, does 61 have any perfect square factors where we can simplify that radical? Okay, those are things you look for to see if you can simplify it all. So this one is done. So all this one needs is curly brackets and we're done. Okay, so sometimes if you get something really gnarly under the radical that doesn't have any perfect square factors, you just get to be done. And it's like Christmas. Okay, it's like thank you, math gods. Okay, flip. All right, this time, do we have standard form set equal to 0?
No, we do not.
We do not. So let's subtract away the 2. We get 3x squared minus 2x minus 2 equals 0. Okay, do we have a GCF to divide out?
No.
Okay, so our A is 3. Our B is
-2.
-2. And our C is
Also -2.
also -2. So we're going to plug them in. X equals, if it's already negative, if I do the opposite of -2, it'll be +2. Plus or minus the square root of -2 squared. Don't forget to parenthesis it. Minus 4 times the A times the C. A is 3, C is -2. The whole thing over 2 times 3. Okay, simplify under your radical. Good, that's correct. So under the radical, it all simplifies to 28. So you should have x equals 2 plus or minus the square root of 28, the whole thing. Can we leave the 2 and the 3 just multiplied together without simplifying to 6? Just write it as 2 times 3 still for now. You'll see why in a little bit. Okay, last time we were looking for perfect square factors hiding inside of 61 and there weren't any. But what can you see inside the 28? Okay, so perfect square factors are things like 16, 9, 4. You see any of those in there? Yeah, 4. 4 times what? Yeah, 4 times 7. So I can rewrite this as root 4 times root 7. And we know what the square root of 4 is. It's 2.
2.
So already this one is a little bit more involved than the last one. So this time we'll have x equals 2 plus or minus 2 root 7, the whole thing divided by 2 times 3. Now, when you have an answer that is like 2 divided by 4, do you see that they have a common factor?
Yeah.
So you just divide out the 2 from both of them, right?
Uh-huh.
And you get 1/2. Same thing here. And this 2 in the denominator is dividing this coefficient 2 and that constant 2. Okay, it's doing both. Because this fraction bar is a grouping symbol. It's saying that this denominator is dividing the entire numerator. We don't get to cherry pick our way through the numerator and what we divide. So what is 2 divided by 2?
1.
Yeah.
Uno.
Okay, what's this 2 divided by 2?
Uno.
Also uno. Okay, we got rid of the 2. What's left in the denominator? 3. And that's the answer. Okay, a little bit more work than the last one, right? Questions about what we did?
Another question though. So why do we just like keep the 2 times 3? Why don't we just multiply together?
Okay, well, let's get in our time machine and go back. Let's say that we had simplified this into a 6. Okay, now instead of a 2 times 3 down here, we have a 6. Isn't it a little bit harder to see that I have a 2 that divides out? It's just a little bit harder to see that there's a 2 in the denominator.
Sure.
If you can see it, that's great. But it might be worth it to like wait until the end to simplify, because then it's easier to see that there's a 2 that's dividing on top and bottom.
Okay. That makes sense.
Okay. It's just a trick I've learned over the years, and it ends up making less work where there was more work. Because what happens if is that you multiply them together and then you just have to break them apart again. Yep. What? Because I have a crystal ball and I knew that nothing was going to divide out. So we could have, this is a decent question. We could have left this as, 2 times 3, right? And then once we see that there's nothing going to divide out, then we can just write it as 6. Okay.
This one.
Yep.
So can we do that with like every problem that we use, whatever this is called on?
Yeah.
Okay.
You can wait till the end to simplify to see the factors in the denominator. That's absolutely a trick you can use to save yourself work. All right. Do we have standard form set equal to 0?
Yes, we do.
Hey, do we have a GCF?
Yes.
Can you wait until we're done with this problem? Okay.
2.
Yep, we're going to divide out the 2 on both sides. So now we have x squared minus 10x plus 13 equals 0. Ooh, our B and C are kind of big. Okay, the A is 1. The B is negative 10. The C is 13. Okay, I want everybody to plug them in.
Okay.
So you should have x equals positive 10 plus or minus square root of negative 10 squared, but it's in parentheses, minus 4 times 1 times 13. The whole thing over 2 times 1. How did you do?
Perfect.
Good. All right. Now we can simplify under our radical. Make sure you put those parentheses in the calculator.
I don't know, bro.
What'd you get?
88. Hold up. Hold up. What now?
Okay, what is 100 minus 4 times 13?
What did you want?
Yeah, negative 10 squared. What? 48.
48.
Do we need to stop and look at it?
Hold up.
Okay,
I
so
just went
x
3.
equals 10 plus or minus the square root of 48, the whole thing over 2.
So why don't we just like keep 2 times 1?
Well, 1 times anything is that anything, you know?
Yeah, but I mean still.
Here.
I understand.
You were just being funny?
No, I was just like, it was a serious question at first.
Okay, until you answered it yourself and then it became funny?
That was kind of funny.
All right, so perfect square factors, 25, 16, 9, 4. Do you see any of those that evenly divide 48?
4. And 16.
4 and 16, so which one do we want?
16.
The biggest, right? We want the biggest. Okay, so how many times does 16 go into 48?
3.
Correct.
3.
So what is the square root of 16?
4.
Correct. So we'll have x equals 10 plus or minus 4 square root of 3. The whole thing over 2. Now, what do you think is going to happen to our 10 and our 4?
They're gonna divide by 2.
They are going to divide by 2.
5.
So we get x equals 5 plus or minus 2 square root of 3. Any questions? No? Do we need to do any more or are we good? Good or one more?
C.
See what? Can't just say see.
One more? Okay, if you're ready to start your assignment, you may do so quietly, but we're going to do one more. Okay, do you guys want C or D?
D.
D? Okay. So do we have standard form set equal to 0?
No.
No, so we have to subtract away the 7. So we'll get 2x squared minus 2x minus 7 equals 0. Our A is 2, our B is negative 2, and our C is negative 7. Okay, go ahead and plug those in. Okay.
I'll get back to you.
All right, how did you guys do? Okay, I didn't do this one today, so I don't remember it. And my mental math is not bueno right now. Okay, I can do it. Okay, 4 times 7. What's 8 times 7? 56?
Yeah.
Okay, 56 plus 4. I'm getting 60. Okay, so x equals 2 plus or minus the square root of 60. The whole thing, I'm going to leave it as 2 times 2 for now because I have a feeling there's going to be something inside of the 60 I can take out. I think the biggest perfect square factor in 60 might be 4. Is that right?
What was the question?
Is the biggest perfect square factor in 60 4? I think it's 4 and 15. Is that right? Because 2 times 30 is 60. So 4 times 15. Does that sound right?
That is correct.
Thank you. Thank you. So what is the square root of 4? It is 2. So we get x equals 2 plus or minus 2 times root 15, the whole thing over 2 times 2. Okay, I want you to simplify it on your own. I'm going to come around and check.
1 plus minus 1, square root of 15 by less than.
Good. 1 plus or minus 1, square root of 15 divided by 2. Okay, don't forget your curly brackets, and you're done. Ta-da! Are we good? Okay. Thank you for playing.